Assalamu alaikum everyone. Welcome to week 8, lecture 22 for CS116 object oriented programming. So let's begin. Last week we discussed two topics. The first one was polymorphism. In fact, this leftover topic, abstract classes, like this was the only topic that was left in polymorphism. So we did this last week, and we also discussed some supplementary concepts like how to make properties and what is duck typing. After that, we spent the remaining two lectures on exceptions, and we also saw a comprehensive example in the end. In the three lectures of this week, I'll be discussing a case study. Actually, we'll be developing a small application, but complete application. Like we'll start from the design, and then we'll come to implementation or coding, and then we'll also discuss any future expansions for that application. So the application that I'm choosing here is a quiz game. I think I don't need to define this quiz game. All of you must have taken a number of quizzes, online quizzes, especially during this semester. It what this application will do, it will simply display some questions in front of user, and it will give some options to choose from, and it will calculate some scores, and then it will display those scores at the end. Now we cannot start coding right away. We need to design the application first. Like we need to think about different aspects of this application before starting to code. And since we are going for an object-oriented design, so we must work on the design first. We must work thoroughly on the design first. So let's see the thought process. How should I begin? First of all, I need to know how my application would look like or would appear to the user. Like I should think about the interface that would appear to the user. Keeping that in mind, I can start designing my application. And we have been doing this the same way during the last semester as well. So what you can do, you can explore different online applications which offer quizzes, so that you may know what kind of interface they offer. We will not go for a GUI. We'll simply keep it on, we'll keep the output on the shell, but still what kind of options they provide, and how they display questions, and how they take the answer, you can see that from various applications already available on the internet, right? So the point here is that you should have a fair idea about the user interface before starting to design it. After finalizing the user interface, you need to identify the objects in your application. Because we are opting for object-oriented design, we need to see what are the entities that can be converted into objects. And then for each object, we'll code a separate class. So you need to identify the objects, you need to identify the attributes and methods for each object. We know attributes and objects means the data and functionality related to each object. And then you'll also have to think the structure of those objects, like how will you store data in those objects, whether you'll use lists or you'll use dictionaries, or how will you organize your data within an object. Then apart from this, your application might need to keep some information permanently in files, so you have to decide that too, like how many files you need to create, and what information will you keep in those files, and in what format will you store that information. That means you have to finalize a class diagram for this application first. So this is how we'll go about. We'll first design our application. So in today's lecture, we'll think on all these lines, and we'll see how we can design or finalize a class diagram for our quiz game. And after that, we'll be coding our application. By coding, I mean we'll start writing code class by class. So once you have finalized a class diagram, a good approach is to focus on a small part of code at a time. So we'll start with the simplest class or the most basic class. We'll write code for that class, we'll test it. Similarly, we'll do that for all the classes, and then we'll integrate everything in the end, right? So that is a very good modular approach. Now, as I have told you earlier as well, that the more time you put on the design stage, the easier the implementation becomes. So although it's an iterative process, you can always come back to design stage even after you have started coding, and then you can refine your design, and then you can go back to the coding stage. It's an iterative process, but the better the design, the lesser time you'll spend on the code, or you might not need to come back to the design stage at all. So that's why we'll spend a good time on the design process first. Okay, let's start discussing the user interface first. In the simplest form, what we can do, as soon as the user clicks the application asks the user if he or she wants to start a quiz. And on clicking that option, I can display 10 or as many questions as I want to the user one by one. I'll collect the response from the user. I'll check that response against some recorded answers, and I can calculate score and I can display that score. So this could be the simplest interface. So the application starts, it asks the user to start the quiz. As soon as the user clicks this, the quiz will start. But when the quiz will start, what will happen? We'll start displaying questions. For those questions, we need to have a question bank. So and as you can see, I want those questions to appear every time the user starts that application. That means that I must store this question bank in a file. So I have a question bank. I randomly choose 10 or 5 or as many questions as I want from that file, and I start displaying those questions one by one to the user. So I'll display a question, I'll get the response from the user, I'll compare it with my already saved response in my question bank, I'll update the score, and I'll repeat this process as long as I want, like for 10 questions or for 15 questions or 20 questions, or as long as user wants. We can provide that option also. And after that, the game ends. It displays scores and it ends. This could be the simplest interface. Okay, now what can I add to this simple interface? I can provide user option to select a topic from some given topics. Let's suppose I allow the user to choose from two kinds of quizzes, science quiz and a general knowledge quiz. So in this case, how the interface should look like? The application will start as soon as the user consents to take the quiz. He or she is presented with a couple of topics. Let's suppose two in this case, a science quiz or a general knowledge quiz. Now, since here we are making two quizzes, two types of quizzes, that means we need to make a separate question bank for each. So I can maintain a separate question bank for science quizzes, and then I can maintain a separate question bank for a general knowledge quiz. And the remaining process stays the same. Okay, whichever type user chooses, science or general knowledge, the remaining process is the same. We'll display questions one by one, we'll input the answer, we'll check that answer, and we'll update the score, and in the end we'll display the score. We can put whole this thing in another loop, like if user wants to take another quiz, we can do that as well. So this is the second option. What more can I add? One more thing that I can add is quiz management. Now this is not for the person who is taking the quiz, but it is for the administrator of that application or the manager of that application. That, like, if he or she wants to update the quiz, we want to make an interface here which will help that manager update the quiz. Like he can, or she can add questions to the quiz, remove questions from the existing question bank, and can view what is there in that question bank. So let's see what we'll have to do for this. As soon as the application starts, we can provide two options. Like user can choose what he or she wants to do: take quiz, manage quiz. For manage quiz, we can also ask for a username or password. uh, okay, this side remains the same. Actually, this was a simpler version where we are not offering topics to the user. Coming to the other side, what options we can provide in manage quiz? We can display, if user chooses this to manage quiz, and if he or she enters a valid account information, what we can do, we can display another menu which will help the manager choose any of the operations, like view question bank, or remove questions, or add questions, right? So this could also be an extension to our application. Like we are providing an interface for the manager as well, so that he or she can handle or manage the quiz easily. And a last option that I could think of here is that I combine or that option 2 and 3. Like I give the user choice: he or she can manage the quiz, or he or she can take the quiz. And in taking the quiz, he is offered, choice of topics, and the remaining process stays the same, right? So I can pick any of these as my chosen user interface. Okay, I'm choosing option 3. Like I'll make these two options: a user can take the quiz, or he or she can manage that question bank, or make changes to that question bank. I'll provide an interface for that too. And the main part is this purple one. Like uh, i'll I'll maintain only one question bank, and I'll ask user, the person who is playing or taking the quiz, I'll display questions one by one, and then I'll calculate the score. So this is what we are going to build. So now let's identify what objects we can make in this scenario. Now, one of the basic objects that I can identify in this scenario is a question. Question could be an object. And that means that I'll make a class for this object question. And what that class will do, it will only maintain a single question. Like I'll decide what field should I keep there. Like a complete question means the question, the options, and the correct answer. And then I'll provide some supporting methods for it. So we'll discuss those attributes and methods shortly. Let's see what other classes we can make, or other objects that we can identify in this scenario. Now, you see this object question, it holds just one question. And we need to maintain a question bank here in this application. So another class that I can make here is a question DB. Now, it's this question DB, what it will do, it will simply maintain a question database or a list of questions. And each question will be of question type. And by question type, I'm referring to that first class that we defined, right? So this can be our second class. Now, what kind of functionality can this class provide? It can allow the user to view that list, like whatever questions we have in our question bank, we already have in our question bank. Then it can allow user to add a question to that question bank, or remove a question from that question bank. And one important thing that this class should do, it should be able to store the list into a file, and should be able to read a list from the file whenever needed, right? So you can name this class as question bank as well, but okay, this is the name that I have been using in the code, so let's stick to this. Now, these two classes that we have defined so far, they'll help us maintain the question bank, and they'll also help us implement that green part, like manage quiz part. We can provide all those functionality in this question DB class. Now, this purple part is left, which is the main part, the quiz part. So we can define another class create quiz or simply quiz, and this class will simply create a quiz. So what kind of functionality should it provide? It should be able to select some questions from the question bank, like randomly. It should it should randomly select some questions from the question bank. It should be able to display those questions to the user one by one, and then it should be able to calculate the scores, keep track of the scores, and calculate the scores and display those scores at the end. So this is the main class which will implement this purple portion of our diagram. Lastly, we need to write some code that will glue all these classes together. Now there are two options for that. Either you can write the whole code in your main program, in your main file, and there you can display different types of menus, and you can take users selection, and then you can instantiate and call objects of any of these three classes. This could be one option, and the other option is that you put everything that you plan to do in the main program in another class, and let's call that class, this is the option that I'm going to take. Let's call that fourth class user interface class, and what it will do, it will simply display the options to the user, and it will take input whatever user chooses, and then it will create objects of these classes as per requirement, and it will continue the game. So if I do this, then in the main program, the only thing that I'll in the main program, I mean in the main code, what I need to do, I just need to instantiate an object of this user interface type, that's all, and my game starts, or my application starts. Now let's start defining these classes. By defining these classes, I mean I'll identify proper attributes and methods for each of those class that we just listed in the last slide. So the first class is this class question. It was meant to maintain a single question. So what attributes can I have? A question can have three parts. The main question, right? Then some options. Let's suppose I'm fixing three options for my application, and then there should be the correct answer, right? So this is going to be a complete entity. So it will contain a question, three options, and then the answer. What methods can we have here? The first method is surely going to be the constructor. We'll decide shortly what we place here in constructor. Then we should have some setter method for these three fields, like user should be able to set a new question, he should be able to set some options for that questions and correct answer for the same question. So there should be some setter functions for all these three attributes. And then we should have some print options, like we should be able to print the question, or we should be able to print the correct answer, or we should be able to print the whole thing, the question, the options, and the correct answers. So we can provide a variety of print functions here. And one important function that or method that we can add here is check answer method. Now what this will do, it will simply pass a parameter, or which is to be treated as answer, and it will simply check that answer against the stored answer or the correct answer attribute of that particular question. So this can also come handy in our application. So let's define this method too for this class. So this is what I was just telling you about the parameters of check answer method. Now what else can we decide here? We can decide how to keep these attributes in our class. Now see, there can be two methods for this. The first one is to use separate instance variable to store each of these attributes. Like I make an instance variable to store that question prompt. I make another for storing options, and a third one for storing correct answer. Now for options, again, you have two options. Like you can make a different instance variable for each of these three options, like option 1, option 2, option 3, or you can maintain all these three options in a list. I make a list of 3 items, and I store these 3 options in that list. So it's up to you how you define your instance variable. Another choice that we can have here is that we can store all these attributes in a single list. Now, how can we do that? Again, we have multiple choices for that, but this is the format that I'm choosing. I'll make a 2D list. A question will be stored as a string as first item of my list. Second item would be another list, another sub list, which will keep all the three options. Again, these options will be of string types because they are actually the answers to that question, possible answers to that question. And lastly, I'll store the correct answer. Now, for correct answer, again, I have more than one choices. Like I can store the actual answer here in a string form, or I can store index number from this middle list, option 1, option 2, and option 3. Option 1 is at index 0, option 2 is at index 1, and option 3 is at index 2. So I can store a number here as well, like index or 1 2 3, or the index 0 1 2, whatever I want to. The point here is that I'm storing an integer at this place, and I think this will be the most handy thing because I need to fetch the correct answer and I need to compare it when the user selects any of these options. So I think this will be the easiest way to do that. So I'll store a number in place of correct answer, the number of the option, the correct option, right? So now you see, I'm using this list. There could be certain benefits to this. We all know that there are some built-in functions supported on lists because list is a built-in class. So we can take advantage of those methods also, like built-in methods are supported on this list class, so we can take advantage of those built-in methods also. Then when I'll be writing this question into a file, I'll have to store my question bank into the file. So when I'll be writing this question to a file, this format is the most appropriate one for that. Like I'll just have to write this list into the file. So that would be an easy thing to do. But both these options are open. You can choose any of these two. I'm choosing this second one. Lastly, we can think about the constructor, like what to place inside the constructor. Although it's not necessary to think about the constructor here, we can decide this at the coding stage as well. But for practice, let's do that. What I can do in the constructor, I can simply initialize an empty list. So this is the first option. Or I can provide a constructor that initializes a question. And for the second option, the user will have to provide 5 parameters: question, option 1, option 2, option 3, and then correct answer. So I can implement that also. So I'm selecting this. I'll initialize to an empty list because later I'll show you that I won't be initializing this question here. I'll be initializing this question in some other class. So in any case, you can choose either of these two. I'm choosing the first option. So here's our class. This is what we have decided. We'll keep only one attribute. It's going to be a list. And then we have all these methods that we'll be writing for this class, right? So now see, this has now become easy. We'll just see this class diagram and we'll start implementing it method by method. We'll test this class separately and then that class is ready, right? Now let's repeat the same thing for the second class. I mean the same thought process for the second class. The second class was QuestionDB, and what it was supposed to do, it was supposed to maintain my question bank. And in question bank, I'll keep a list of all the questions that I'll be offering to the user as part of my quiz game. So what I'll do, I'll make a list of those questions, and each question could be of that question type that I defined on the last slide. That means now question is a type for me. So I'll make a list having entities of question type, right? Now, one thing that I would like you to note here is that I could have merged these two classes. Like I don't need to define a separate question class. I could have put all those methods and attributes here as well. But that could have made this class unnecessarily long. Like a good approach is to divide your program into as smaller pieces as you can. The more granular is your code, the easier it is to write code, and then especially to debug the whole thing. So just break it into smaller parts, write code for each part, test that part, and then integrate them all. So here now, after coding that question class, we are sure that that class works fine. We'll just use that class here. So what attributes do I need here? Just one attribute, list of questions, and we know that these questions will be of question type, right? Coming to the methods, first method is going to be the constructor. Again, we can define an empty list in the constructor. That could be one option, and I'll show you another option shortly. Then we can provide a method to add question to our list. Now, this add question will create a new question. Actually, it will ask user for a new question, it will ask user for 3 options and then for the correct answer, and it will create a question type object here that will be placed in the list. So this method will be calling methods from our question class. Then remove question from the list, this will simply call pop or remove method of list data type, and that's an advantage of keeping all these things in list. I can use this built-in method remove or pop. Then we can print the question list, whole thing, like the whole question bank. Now this is the most important thing, one of the most important things for this class. Once you are creating a question bank, you would like to save it in a file, because you don't want to enter all the questions each time you run that application. You want those questions or that question bank to load automatically from some permanent storage like file. So these two functions, save list to file and load list from file, they'll just save my question bank into the file and will help me retrieve that question bank from the file. So this is another option for constructor. What we can do whenever I instantiate an object of question DB type, so what it does, it simply loads a question bank from some file, right? So that means as soon as I instantiate an object of this type, I'll have my question bank ready, that question bank that I have already defined in some file, or before using these add question methods. Now saving to file, what options do I have when I save my list to file? I can save that list question by question. I know this is a list of questions. My main instance attribute is a list of questions. So I can write questions by question into that file, or I can write the whole list as a single object to the file. So this is what I'm going to use, because I'll show you shortly that this will organize the file in a better looking way. So if I open my file and try to see the questions, each question will appear on a separate line. Whereas in the second option, all those, they'll appear, in a single line. That is not very readable. And you can try that if you want, but I'll store question by question, and that will store each question on a separate line in a file. So this is my second class. Here's the summary, or is the class. Only one instance attribute, and there is a list of functions. Now str function, okay, this function was there in the last class also. We can always implement this function to provide that print functionality for our class. It's optional. If you want, you can implement it. If you don't want, just don't go for it, but it will give your class a better look. Now, those two classes which we have just finalized, they were basically maintaining our question bank. Another important class is this class quiz, and the purpose of this class was to create a quiz. So what we'll do, if you want to create a quiz, we have a question bank. We'll randomly select some questions from that question bank, and we'll display those questions to the user for the quiz game, right? So what attributes can it have, this class have? Now this class should have an instance attribute that holds my question bank. So I can create an instance attribute of question DB type here. That means this attribute will contain whole list. So I'm making question DB part of my this new class quiz. So again, we are using composition. And then I'll define another list. It could be a simple list and it could be a list of selected questions. So what I intend to do, I intend to randomly select some question from this question DB, and I'll put those questions in this selected question list. Now the methods. First of all, the constructor. I have a couple of ideas here regarding constructor, but I think it's better to talk about it while coding. So let's keep it till then. Another method that I can add here is make quiz. This is the main method. Now what I want this method to do, this method will access this list of questions of question DB type. Like it will access my question bank, and it will randomly choose 5 questions from that bank, and it will place those randomly chosen question into my second list, the list of selected questions. So this is what this method does. Then I need another method. Now I have a list, a prepared list that I want to display to the user. So another method could display that list to the user. So display quiz method, it will simply use that selected question list. It will display those questions one by one to the user. It will take answer from the user. It will compare it with the pre-stored answer, update the score, and then it will go to the next question. So it will do this 5 times. I'm using 5. You can increase it to any number that you want. So this could be another method. And then I can have another method that will print score. I can print this score in the display quiz method as well, and I can have another method as well. So it's up to you how you organize it. So this is the class that I have defined. This QDB is my first instance attribute of question DB type. This is the name that I used in the code. So let's stick to this now. Otherwise, I think I could have chosen a more appropriate name here or a more descriptive name here. Okay, second name is fine. Selected questions list, that is self-explanatory. And then the 4 methods that I decided. Coming to the last class, the user interface class, it will simply display the options to the user. It will display certain menus, and that's it. It will instantiate objects of those 3 classes that we have already defined. So I think there won't be any attribute in this. We'll see while coding if we need some, but for now I cannot think of any attribute. Now what methods can it have? It should be able to display certain types of menus. uh, we can have a constructor, and that constructor can do everything. I'll show you why I'm doing everything in the constructor. That will make the main program easy. You will just have to instantiate an object of user interface, and that will do the whole thing. I'll show that to you in the next lecture, of course, when we'll come to coding. Okay, I can write a method to display the main menu. Main menu can display 2 options, whether the user wants to take the quiz or whether he or she wants to manage the question bank. One thing that you should note here, that I'm not putting any username password type thing here, so that can be added later if you want. But right now, if user wants, he or she can alter the question bank as well, or he or she can take the quiz. Okay, now if the user wants to take the quiz, that is a fixed procedure. Like my system will select some questions and it will start displaying those questions, and that's it. But if the user wants to edit the question bank, then again I need to display certain choices, that whether he wants to see the question list, whether he or she wants to add questions or remove questions or whatsoever. So that could be another menu. And then I can write a method to manage that second menu. So these 2 central methods are simply print methods. They'll print some menus, whereas the last one will help me choose an appropriate method when user chooses something from that edit menu list. So here's the class. So now we have 4 classes. So these are our finalized classes. This was class 1 question, then second class question DB, third class quiz or create quiz. I think create quiz would have been a better name, but I've already done all the coding using this name, so I cannot help it now. Okay, this is the fourth class user interface class. Now let's see what relationship exists between these classes. Uh, we know that we'll be using this question class within question DB. So I think composition is the best choice. And then we'll be defining instance of this question DB class in my create quiz or quiz class. Actually, QDB is of question DB type. So again, composition. And from user interface, I'll be calling both these classes, because if user chooses to run a quiz, then I'll be instantiating an object of quiz type. And if the user chooses to manage data bank, then I'll be instantiating an object of question DB type. So they both will be part of the user interface class. See, now let's analyze this with those requirements that I provided to you for your term project. I asked you to make 4 user defined classes. So here, this project has 4 user defined classes. I was able to make or decide on these 4 classes easily. Now let's see how many features does it have. It should have at least 4 object oriented features. So it's implementing association, it's implementing method overriding, VR overriding, init method, and str methods. Then I can implement exception handling, of course, at many places. Okay, apart from that, I am not implementing method overloading, sorry, operator overloading, or I'm not using inheritance at all. So it's lacking feature according to those requirements. So what I can do here, I can move these methods of question DB class, load question list or print question list. I can move them or convert them to mix-in classes. Once I convert them to mix-in classes, then question DB will be inheriting from these 2 classes. So that will incorporate inheritance also, or multiple inheritance also, in my project. So see, there are different ways of designing the same thing. Okay, that's all for today. But before ending, I would like to show you something really interesting. Now, here is the class diagram or the UML diagram in Star UML. What I wanted to show you here is that these softwares like Star UML and other such softwares, they are able to generate some initial code for your application as well, seeing your class diagram, like kind of template. So let me show you that. You just go here in Tools, Extension Manager. Now you see a whole list of tools is listed here, like Rebel, CodeStar, Django, Ruby, PHP. These are all different kinds of languages, Java. And here in this list, you'll find Python. You just install it. I've already installed it, so that's why this is disabled. This is showing disabled here. Otherwise, you can install any of these extensions. You just close it. And once you have installed it, it will appear here, like Python is appearing here. You'll just go to generate code. This is my model, the model of my my diagram. Okay, you have to create a folder. So let me create this folder in, let's suppose, documents. So here I create a new folder, test code, let's say, or whatever name you feel like. I select it, right? And that's it. Now let's go there. See, here is the folder. And if I click it, here are the files. These are the 4 classes that I have made. So let me click any one of them. See, this is the template of your class. It is showing a constructor. It is initializing your instance variable in that constructor. And here are those 4 methods. Now, see, this is just a template, but it can be very helpful. Like, you do not have to go to the class diagram again and again to see what methods you decided on. So this is really cool. Now let's go back to the slides. So let's have a quick recap. We decided on the user interface for our application. We decided on the number of objects or number of classes. We decided attributes, method, data structures for my attributes. All this we did today. Now, there are certain things that I would like you to remember, or that I would like you to note. See, there were choices at every step. So that means there is no definite process for an object-oriented design or any programming design. You always have choices at different stages, and each of these choices, they have their own pros and cons. So this is what I meant by that MCQ 16 in quiz 1. Like, there is no definite method to build an application. There are always multiple choices, and the choices that you make you a good programmer or a bad programmer. And we spend a lot of time today on just design, and I'll prove this that in next lecture, that since we have completed the design, we only have to write code. That's it. And we do not have to think about this design again and again. So sometimes you have to come back to the design process again, even after starting coding. It's an iterative process. But if your design is strong, if you have spent well enough time on that design, then that would make the implementation a lot easier. That's all for today. Thank you.